Hello everyone, welcome to Chemistry at your fingertips. Now this is basically the final video of the chapter alcohol, phenols and ethers, basically the end of the textbook questions. Okay, so today we are going to do the final few questions which are there in the textbook. Okay, so first of all, this is the third video for alcohol, phenols and ethers, and I hope the previous two videos were useful. Okay, so before I begin the video, if you like the video, please hit the like button and make sure to subscribe and hit the bell icon so that you can get periodic updates regarding any new videos. Okay, of course there are going to be videos from other topics as well, the end of the textbook questions and what should be your preparation strategy, what are the things that you should focus more on while you are preparing. Okay, for in order to get these information you need to just have updates regarding any new videos that's going to be there in this particular channel, right? So now let's begin the alcohol, phenols and ethers part 3. So you have the first question in front of the screen. Okay, so first have a look at this. So you have an ether A and it is heated with excess of hot HI. These are the keywords which I'm just marking this. Okay, it produces two alkyl halides. Okay, and two alkyl halides they have given. That means it's going to be different. Otherwise, they would have given you 2 moles of alkyl halide, right? Yes, and this on hydrolysis produces C and B and C. Okay, now oxidation of B is going to give an acid D. Okay, whereas oxidation of C is going to give you a ketone, right? So can you just actually understand what exactly happens? Okay, so let's say you have an A. Okay, A is nothing but an ether, right? A is basically an ether C5H12O, right? So let's first write down what exactly. Now this on heating with excess of HI, hot HI, right? Excess. So I think I'll write here excess over here, and it produces alkyl halides. Okay, so it produces alkyl halides. So I can write it as R1X plus R2X, right? R1X and R2X, correct? And this on hydrolysis, so I'm going to write here OH minus, and this is going to give you B, right? And this on hydrolysis, we already know it's going to be an alkaline hydrolysis. This is going to give you C, right? So you have B and C over here, correct? Now oxidation of B, okay? So now let's see, B oxidation, it's going to give you an acid, right? This acid is D. Now here the oxidation is going to give you a ketone E. Okay, so this is basically the entire flow chart or anything that you would say, right? So now let's try to do it one by one. Let's try to understand this question. It doesn't look that easy, okay, but of course actually it's very easy. Now you already know there are 5 carbon atoms, so the ether is going to be a mixed ether. There is no possibility that it's going to be a what do you say? It's going to be a simple ether, right? So what could be the structure of A? The structure of A could be CH3, okay, and then you have a CH2, and then you can have something like O, and there is going to be CH, there is going to be a CH3 over here, there is going to be a CH3 over here, right? So this is basically the structure of the ether. Now there is one more possibility, so I'm going to write here or. So I'll have CH3 and then I have O and then I have a CH, not CH, right? So I'm going to write a C over here, there is a CH3 here, and there is one more CH3 and there is one more CH3, right? So there is a possibility that this also may be correct, right? So now what does it give on treatment with HI and followed by hydrolysis? Okay, so let's try to work it out. Let's try to work it out backwards. Okay, so now you get a ketone. You know, C, you already know it's an alcohol, right? And it on oxidation gives a ketone. That means ketone with same carbon atom. They haven't mentioned anything. You have to take it as it is, right? So this is going to be secondary alcohol. Now can you see here, this is the tertiary carbon. Okay, this is the tertiary carbon over here. So that means this is completely ruled out. Okay, that means we don't want any tertiary alcohol at all, right? So this is completely ruled out. Now we already know A is this structure, right? So we already know A is this structure. So what I'm going to do is, let me just erase this out. Correct. Let me just erase this out because we already know this is not the right structure, right? And anyway, you will be making notes for this, right? So now this on treatment with HI. So I'm going to use 2 moles of HI because it's written excess. So the bond breaks, I comes here, I comes here, right? And then you have 2H over here. So what is that which you get? You get CH3, correct? And then you have CH2I, right? And then the next one is nothing but CH3. Okay, let me just make it easier for you, right? So this is, and then plus I have CH3, okay, CHI, and then CH3, correct? So now this on hydrolysis. So I'm just going to write hydrolysis. So what is that which you get? CH3, CH2OH, correct? And this is nothing but your compound B, right? This is your compound B. And then plus you have CH3 and there is CH, there is going to be OH, and then there is going to be CH3, correct? So this is 2-propanol and ethyl alcohol, and this is nothing but your compound C. Correct. Now what else is there? What else is there? Now very interesting thing you are going to do. So you are going to do the oxidation of this, right? Oxidation. So I'm going to do the oxidation of this. Let me just make it a little bit lighter. So this is going to give you an acid directly, CH3COOH, and you have got A, B, and C. This is going to be D, and then this is going to give us a ketone, because we already know that, secondary alcohol gives us a ketone. This and this is E, right? So now here we go. We have everything sorted out now. Okay, so let me just put this in a block or something. Okay, so we have, this is A. Okay, this is A, which is known to all of us. Okay, let me use a better color. Yeah. And then this is B, right? And this is C, and then you have D, and then you have E, right? Now it's your choice whether you could write down the formula, name of these compound, but they have just simply asked the structural formula, so I don't think you need to bother much. But it's always better if you write down the name as well. Okay, so this is basically the correct answer. Okay, so I hope you have understood this. Okay, now let's move on to the next part. Okay, so here we go. We have the next question. So this is asking, write the structural formula for the following. Okay, so let's see this 3-methoxyhexane. So you have hexane means carbon, 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 and then there is one more carbon, and then there is one more carbon at position 3. So there is a methoxy group, correct? Now very simple, balance everything. CH3, CH2, this is CH, and then this is CH2, this is this is CH2, and then this is CH3. Very simple, 3-methoxyhexane. Then 1-ethyl cyclohexanol, correct? So this is cyclohexane, this is cyclohexanol, and then there is one ethyl group. Very simple, correct? Write the structural formula. Then you have methyl vinyl ether. So what is vinyl group? Vinyl group is CH2 double bond CH. This is vinyl. And then you have ether. So I'm going to put something like this. Very simple. Okay. So let me just put everything in block. So this is one, this is another one, and then you have another one as well, right? So it's very simple. Write down the structural formula. Okay, now let's move on to the next part. Now you have pentane 1,4-diol. Again, very simple. So what I'm going to do here is I'm going to draw 1, 2, and there is this 3, there is this 4, and then there is this 5. At position 1 and at position 4, you have the functional group, that is OH, because it's a diol, right? So here 2 bonds are done, so it's going to be CH2 It's going to be CH2, it's going to be CH2, CH, and then there is going to be CH3. Very simple. Then you have the next one, cyclohexene, hex 2 in 1 all. So you have one all over here. Now the double bond is between, it's 2 in. So you have 1, this is 2, and this is 3. So the double bond has to be between 2 and 3. Hex 2 in 1 all. Very simple. Okay. So let me just write it down. So this is the first one, and then you have the second, right? So these are the structures, very easy structures and simple structures, right? Now write down the IUPAC names for the following. Now this is going to be more easy because IUPAC names are pretty much simple to do. Okay, so let me just write down the numbering. So this is basically the numbering 1, 2, 3, 4, 5, 5. So it's going to be pent. No double bond, that means ane. Cyclopentane. With an OH group, it's going to be cyclopentanol. So 1 methyl, 1 methyl. Okay, cyclopentanol, right? Now let's see the next one. Okay, the first part is identification of the parent chain. So if you already know, this is the parent chain, right? This is the parent chain because it contains maximum number of carbon atoms. Now the numbering, you are going to do it from 1 to 2 hydroxy 3 methyl, right? 1, okay, you have, how will you start the numbering? Obviously you'll start from here because closer to the functional group. 1, this is 2, this is 3, this is 4. I didn't actually see this OH, that's the reason I started it from the other way, right? So let me 1, 2, 3, 4, yeah. Let me just get rid of this. Okay. So you have 1, 2, 3, and 4. 4 means but. Okay. No double bond means A. So you have butane. B-U-T-A-N-E. Butane, and there is going to be 1,3-diol, 1,3-diol, right? And then at position 2 you have a methyl, so it's going to be 2 methyl butane 1,3-diol. Okay, now let me see the third one. Third one is pretty much easy. Okay, so you have, this is the major functional group, this is the secondary functional group, so it's going to be 2, sorry, okay, it's going to be 2 nitrophenol. Okay, and then you have fourth one, it's going to be methoxy, right? And this is the cyclohexane. So you have so you have methoxy cyclohexane, right? Methoxy cyclohexane. I think this basically takes care of everything. Okay, so I guess I think these four are over. These are very simple actually, so I don't think you should have any problems when you're discussing all these things, right? So this is A, B, this is the first one, second one, this is the third one, and this is the fourth one. I guess I think now everything should be all right, right? Okay, so I think that's the end of the textbook questions. I hope you have enjoyed watching the videos. Now, regarding the next upcoming videos, it's going to be for aldehydes, ketones, and carboxylic acid. Okay, once I'm done with that, I'll be doing amines, followed by biomolecules and polymers, then DNF block elements, and the transition and inner transition elements. So let's see how things go. So in the meanwhile, just make sure that you are doing everything simultaneously, watching the video, because that's going to be the best part. And after a period of after some time, the videos are going to be removed. Okay, so just make sure you finish it off well before it's removed from the like this platform, right? Okay, so I hope you have enjoyed watching the video. Thank you very much.